Good day, everyone. Welcome back to another episode with Practice Mathematics with Adi. Alright, so we are still on limit, and in the last video we were able to look at the properties of limit. So today we'll be looking at some examples under limit. We'll be looking at some examples under limit. Now, under limit, there are some important things that we need to take note of. There are some things that we need to avoid under limit. Don't forget, I told us that limit is just a direct substitution. So things to avoid when you are dealing with limits, things to avoid. We avoid anything like anything over 0. We avoid 0 over 0, and we avoid infinity over infinity, and also a complex number. So these are things that we avoid when it comes to limits. Alright, so doing the first examples, I'll be solving some examples for us, and I want us to follow. So example 1 says lim x tends to 2 into x squared plus 1 is equals to, don't forget I told that it's a direct substitution. So whenever you see your x, you put your 2. That's just the meaning. Anywhere you see your x, you put your 2. So this can be written as 2 raised to power 2 plus 1, which is actually 4 plus 1, and that will give 5, which is actually 4 plus 1, which gives 5. That's 4 plus 1, which gives 5. Alright, so that's very direct. Number 2, you can see something like lim x tends to 3 into x raised to power 3 minus 9. So what you just have to do is substitute. That's 3 raised to power 3 minus 9, and that will be 27 minus 9. And our 27 minus 9 is equal to 18. 27 minus 9 is equals to 18. That's another question. Then question number 3 says we should lim, now this one deals with infinity. X tends to infinity, 5x plus 1 over x. Anytime we have infinity, the first thing that you need to do is you break it down. You break down your fraction. Yes, you break down your fraction, or you divide by the highest power of x. So looking here now, the highest power of x is x. The highest power of x here is x. So meaning I can divide by x. But instead of that, we can actually break it down this way by saying lim x tends to infinity into 5x over x plus 1 over x. Like you are dealing with a partial fraction. Don't forget, if you have a plus b over c, it can be written as a over c plus b over c. Exactly what I did here. So meaning 5x plus 1 over x also can be 5x over x plus 1 over x plus 1 over x. Alright, so let's continue with the solution. So we can write this as lim x tends to infinity. So this x can cancel this x, so I left it 5 plus 1 over x. So by substitution now, that will be 5 plus 1 over infinity. 1 over infinity is distance 0. The answer that we already have is 0. Anything over 1 over infinity, 2 over infinity, anything over infinity is equals to 0. So we have our 5 plus 0 here, which is actually 5. So that's how to tackle that. Another question says question number 4 now, I guess. So lim 4x squared plus 3x plus 2 over 2x cubed plus 5, then x tends to infinity. Our x tends to infinity. So how do we go about this? Don't forget I told you that for this you divide your denominator and your numerator by the highest power of x. The highest power of x here is x cubed. So we divide up and down with x cubed, meaning 4x squared plus 3x plus 2 over x squared, then over 2x cubed plus 5 over x cubed. over x cubed, and this can be written as ln x tends to infinity into 4x squared over x cubed, can be breaking it down like this, plus 3x over x cubed plus 2 over x cubed over, same thing is happening here, 2x cubed over x cubed, 2x cubed over x cubed plus 5 over x cubed plus 5 over x cubed, and this can be written as ln x tends to infinity into this, in this we have 4 over x, good, this in this we have plus 3 over x squared, plus 3 over x squared, then plus 2 over x cubed over this, in this we have 2 plus 5 over x cubed. So now we can substitute now. So meaning I can say 4 over infinity plus 3 over infinity squared plus 2 over infinity cube, then over 2 plus 5 over infinity cube. Don't forget, anything over infinity will always be equal to 0, even if it is infinity squared. Even if it is any figure over infinity will always be 0. So 4 over infinity 0, 3 over infinity squared 0, 2 over infinity cube 0, then over 2 plus 5 over infinity cube is also 0. So we have this as 0 over 2, which is equals to 0. So that's how to tackle such question. Alright, so let's look at another one. We have question number 5 now, which will be the last one on this episode. So try and watch out for other examples in the next video. Okay, so we have lim x tends to 0 to x cubed plus 4x squared plus x over x squared plus 5x over x squared plus 5x. If you try to substitute this directly, you won't have a definite answer. What I mean by that is, if you substitute directly, you know that will be 0 plus 0 plus 0. The one down also will be 0 plus 0, which is 0 plus 0. Don't forget, I told you we are trying to avoid this. You must not have anything like 0 over 0. So meaning you need to do something with the question. Alright, so looking at the question, something is common. I can factorize x is common here, so we can have 2x squared left plus 4x then plus 1 over the lower part. 2x is common, so we are left with x plus 5. This can cut this, then we have lim x tends to 0 into 2x squared now plus 4x plus 1 over x plus 5. We know that the next thing to do now is we can substitute, which is 2 into 0 squared plus 4 into 0 plus 1 over 0 plus 5, and that will be 0 plus 0 plus 1 over 0 plus 5 is 5, and that will be 1 over 5. Thank you so much. God bless you. See you in my next video.